Hey guys, in this video I'll be telling you how to do this AP Physics 2 question. A small ball of mass 200 grams and charge 60 mu coulombs. So this would be equal to 6.0 times 10 to the negative 6 coulombs. This would be 0.2 kilograms. Is initially suspended vertically by a massless and inextensible string of length 50 centimeters, which is 0.5 meters. Sometime later, a strong uniform external electric field, E, is switched on, and the ball swings to a maximum height where the string makes a 45-degree angle with the vertical, as shown in the figure above. So theta equals 45 degrees, or pi over 4 radians. So, first of all, what the question wants you to do is find the gravitational potential energy gained by the ball. So, the question asks you for delta U. We know that delta U is force times distance. Force is mg, distance is delta H, because we're talking about the gravitational potential energy. And we need to find, we have mass, we have gravity, we need to find delta H. Delta H is the vertical distance gained by the ball, so this would be delta H. We know, let's call this side L, the length. So this would be L. If this is L, then, and this is 45 degrees, then this would also be 45 degrees because these two are parallel. And so therefore this side length would be considered L times cosine of 45. Now L cosine 45 degrees plus delta H would be equal to L. So delta H would be equal to L minus L cosine of 45 degrees. Delta H would be equal to L times 1 minus cosine of 45 degrees. So now we have delta H, we have mass, we have gravity. We can plug in the numbers. And this is really easy to do. Mass would be 0.2, gravity 9.81, or 10 if you want. And then we have delta H. L is 0.5, 50 centimeters is 0.5 meters. 1 minus cosine of 45 degrees. This is root 2 over 2. When you plug in all the numbers, 0.2, you would get delta UG would be equal to 0.287 joules. That would be your final answer. Okay, this is pretty straightforward. Number B, using the law of conservation of energy, this should be learned in AP Physics 1. Find the magnitude of the electric field. So we have to find the magnitude, which is the absolute value, and you can ignore air resistance. So the law of conservation of energy states that the net work done is equal to the change in energy of a system. So the net external work done would be the change in energy of the system, which in this case, the system would be the ball and it would be the Earth. So we know that the work would be equal to force times distance. In this case, we're talking about horizontal distance. So the force would be Fq, the force of the electric field, times the horizontal distance, here to here. This is really easy to calculate. We know that this is L, so this length here would be L sine of 45 degrees, opposite over hypotenuse. Or pi over 4 if you're used to radians. Now we know that the net energy done on the system would be equal to the change in potential energy plus the change in kinetic energy. However, we see that over here the ball is not moving, so the kinetic energy would be equal to 0. At the start, the ball is not moving, so kinetic energy is also equal to 0. So in this case, delta K would be equal to 0. So what we're left with is F Q L sine of 45 degrees equals delta UG, which we have calculated over here. The force is equal to the charge times electric field. So charge times electric field, which is what we need to solve here, and L sine 45 delta UG. Isolate for the electric field, so E would be equal to delta UG over Q times L sine of 45 degrees. E would be equal to 0.287 over, we know that the charge is 6.0 times 10 to the negative 6 times 0.5 times root 2 over 2, which is sine of 45 degrees. When you plug this in, you will get around 1.35 times 10 to the negative 5, and this is measured in electric field, so it would be newtons per coulomb. That would be your final answer.